Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question comes to us from Aaron, K04REA. And he really has two questions embedded here. He has his general license, which he got a couple years ago, and he said that he has a Wolf River coil platinum TIA that's taken along vertical antenna. I tested one of those and was quite pleased with its performance. His problem is that he's happens to chair the infractions committee of his local HOA. So he can't very well have an antenna that is non-compliant. He's got to hide it pretty well. If he can get hold of one, there's an antenna that was recently released by MFJ. I don't know if they have any more of them because they're going out of business. But it's only 18 feet tall. It covers 40, 20, 15, and 10. And it could actually be put in, behind a tree or something like that, where it's just invisible. Another nearly invisible antenna would be an end-fed half-wave dipole, such as sold by the League. It's less than $100, and that uses gray wire, and so that's not so visible. Okay, so now he has the issue I speak of where he can hear others, but they can't hear me. Okay, that is the one use case I mentioned that would talk about putting an amplifier in before you get a better antenna. In other words, you've got a good enough antenna to hear people, but they can't hear you. You can alleviate that situation by adding a amplifier. This is my amplifier here. The power supply sits on top, and the power supply is enormous. It puts out 75 amps. Then you turn on the amplifier down here, and you select either the 40 or the 20 on the thing here. This amplifier gives me 500 watts out, okay, which is just fine for doing that little problem of where I can hear others but they can't hear me. Okay, so that's something that I put together. I paid a couple $100 for the amplifier and more than that for the power supply. It's a very old amplifier, but it's transistor amplifier, and it works just fine. It works to spec. Okay, his question has to do with somebody gifted him, he thinks, gifted. Sometimes when somebody transfers you a boat anchor, you're actually doing them a favor by clearing up space in their basement. Okay, so we're talking about this amplifier. And what this is an old tube amplifier built to old tube amplifier conventions and talking to a brand new radio. Now, there are two signals. You need to send a signal from the radio to the amplifier to tell it when you want to transmit. Okay? It will not go into amplify if the signal is not there. That signal is readily available on the back of the radio here. However, you should note that what you are doing is keying a relay inside the amplifier. Let me explain just for a minute how TTL logic works. The output of a something, and we've got in, out, at the arrow, this is in PN. And then this goes to some sort of a load in, okay, this is in the amplifier, if it's this. This comes out over to here. They're inside the radio, right? Now, watch what happens. There's usually an R here. It's usually 1K or so. Okay, not very much. You'll notice with tubes that the resistor values are very high, and with transistors they tend to be very low. This is called a pull-up resistor. This is connected to the positive rail. Okay, if there's nothing connected over here, this stays high, and this stays on. This is on. It will allow max current. Now, the reason that doesn't waste a lot of current is because when the voltages are such here that this thing will operate, it's not actually drawing much current. So your load, which could be a relay, like this, that will close the relay. Now over here, if you have an output of a TTL device or another transistor, it's a 1 by default unless it's a 0. And the way it's 0 is this goes down through another transistor, okay, to ground, okay, and this gets the high voltage here, and so no current flows, and that's called the high state. And this is set so that it leaves the amplifier in the receive position. If this changes to a resistor fairly low value to ground in here, or does it through this way right here, what happens is this conducts. Now as that conducts, it takes energy from this transistor. You can't flow energy backwards through a transistor. It doesn't work. I guess you can try. You can put a Hoover Dam behind it and it'll give you a satisfying pop, but otherwise you don't do that. So the current comes from here. Now there's enough current flowing that it pulls the voltage down here. The voltage goes down here and it cuts off this transistor. So this relay cuts off and bam, the contact switch up here to transmit. Okay, that's how that's done. If this is new and this is new, this works just fine. This is usually an RCA phono plug. Okay, so you have the jack and the center and the outside is ground. Okay, that's fine. Now they've kept the same thing, but the problem is that in older tube transistors, what's over here is entirely different. You have a voltage that could be as high as like 16 volts or more, and it comes down through the relay over to here. And this is the relay, and the contacts are up here. So if this shorts to ground, that relay closes, it puts the amplifier in transmit. But look, you can get too much current flowing in here and cause this thing to burn out, or your circuitry to burn out. There is a limit in the manual, the send jack. Okay, the terminal goes low when the transceiver transmits. It's an RCA plug. This terminal is used to control an external non-icon linear amplifier. The transmit-receive control voltage and current must be less than 16 volts and less than a half an amp. Okay, so if what the amplifier offers it is higher than that, what you want to do is create your own relay in there. You know that this going to the transmitter will go low, and so you have a small, tiny, like reed relay in here, with a pull-up. Okay, when this is high, then this right here will cause this relay to close the circuit. And then you take that to the amplifier, okay? And so you've got low voltage, low current over here, and you can get usually 12 volts off the back of your radio, okay? And a little reed relay, you can pick up something like that, or you can make this with power transistors or whatever. Anyway, you want a buffer of some sort between the old and the new so that it doesn't break it. Now, your first instinct is, well, can I try it first and see if it's a problem? And the answer to that is absolutely not, because if it only takes once to blow out some critical components in your radio. They're not fuse protected or anything. Okay? Now, there is another connection, and that is the automatic level control. Normally you send into your amp, your radio, 100 watts. Now, it doesn't need that much to amplify. So what it does is it sends back to this an ALC voltage. And this ALC voltage will cut the power. It has a direct control over the power out of the transmitter, and it will cut it down to what it really needs. Now, if this is missing, you have to go through a series of experiments of finding out how much power you need. For my ICOM right here, this will absorb only a certain amount, and that's right here, the ALC jack. Connects to the ALC output jack of a non-ICOM linear amplifier. Control voltage goes from -4 to 0. Okay, now a lot of these old amplifiers would be -16 to 0. So there are a couple of things that you can do. One, drop the ALC, run your rig at the required voltage. That's supposed to be a 2. It looks like a 1. 62 watts gives me max out. Any more than that and this will splatter. Okay. So there's no ALC on this thing. It's kind of curious. Set up in a mobile environment, I guess it's designed for the mobile environment. Anyway, I sometimes forget to turn my radio down. So there's a couple things you can do. And this was just recently suggested to me. And I'm going to put these in the 100 ohm class. Take this, and this is ground. Take this one and run it into the ALC. Because if this goes up to -16 volts, this can only go up to about -4 volts. Okay, which is what this thing will take right here. Now, the problem is interpreting in an old amplifier what the impedance is. I think this will work for you. You want 4 resistors of equal value. I don't think there'll be much more than this. You can do 1K if you want. 4 1K resistors will work also. If this is a real low impedance output, this won't. You'll get weird voltages out. So test it and try it. See what you get coming out, and you can record that. Okay, now here's the thing. When we're dealing with old equipment, not all of the standards are the same. So you have to be a little bit careful to make sure that old tube type stuff that tends to run on high impedance and high voltage, and transistor stuff, which is pretty low impedance and low voltage. In transistors, what's primarily important is current. In tubes, what's primarily important is voltage. They're really very different objects. When transistors were first invented, yes, I was born before that date. In 1957, 1958, when Shockley, Bartine, and one other guy at Bell Labs invented the point contact transistor, at first tried to make amplifier circuits the same way they made tube circuits. And they found out very quickly it didn't work, because tube circuits are built around voltage, transconductance, things like that. But the transistor circuits are built around current. And in fact, the current coming in through the base, and now there's some standard voltage drops and so on, but they're current driven. The current through the collector is some factor beta times the current coming in the base lead. Both currents flow out together and go through the emitter resistor. Okay, so you can do these things to make that thing work. Now, tubes are obsolete except in high power applications. Can you get a legal limit transistor amplifier for your station? Yes, absolutely you can. But they're 50% or so more expensive than an equivalent tube amplifier. Now, in the long run, I've got this very old transistor amplifier. This still works just fine. Okay, full power out, no glitches. If it is glitching, there's something external to the system that's causing it to do so. Tube amplifiers, tubes do go soft, which means that the key parameters in the tubes having to do with voltage ratios, impedance, etc., get kind of bleh. And the problem with a tube is if you abuse a tube, you'll actually change the chemical makeup of the plate in there, which can cause the conductance of the tube to go down. And in other words, the resistance of the tube to go up, and you don't want that. So yes, tubes will go soft. Furthermore, the tubes need to be what's called neutralized. Now the amplifier as it comes to you probably has the tubes neutralized, but I'd check on it. What neutralization for is that you're dealing with a triode, and there's an oscillator, namely your radio. Now the radio in this situation, whenever you use a radio to excite an amplifier, you start calling it the exciter rather than the whole radio, but that's ham lingo. Every tube amplifier has different demands that it makes of the transmitter or the exciter. So you have to be real careful with that. Talk to an old timer. Be very protective of your radio, because you can blow things out in there, and you don't want to, because fixing it often involves a surface mount component of some kind. It's just a pain to do. So best not to blow it out. Best to build an interface or something like that. So there you have it. Yes, you can use that amplifier with your radio, but yes, you need to take some serious precautions, both on the send and on the ALC lines. If you're not going to use the ALC line, then you have to discover the magic point. What you do is you set up a receiver with no antenna on it, okay. Then you transmit into a dummy load. There'll be enough stray RF that you'll see it on the receiver. And you keep turning up the power, and you're receiving on the correct frequency over here until the S meter doesn't go up anymore. If you go beyond that. Now, it may seem, by looking at the meters, you're putting out more power. Yeah, you are, but not on the right frequency. You're splattering. You're putting junk all over the ham bands. You don't want to do that, not the least, because some hams have pitchforks and can show up at your door. I mean, this is one way to really get your neighbor excited. Don't splatter. Be a good ham. Be a good example for everybody around you on how you set up your equipment. The ARRL is coming out with what it calls the Clean Signal Initiative. And instead of CSI Miami, this is CSI Newington. Okay, it's about cleaning up the outputs of our radios. And they have some things for us to do so that we don't mess up overdriving our equipment, and also things for the transmitter makers to do to help keep phase noise down and stuff like that, to make the radio bands a little more friendly. So that's the long way around the barn. I hope that answers your question. Now, I want to note in passing, and I'm very sorry to Aaron. There's a bunch of old emails I found, and this actually dates from January of 2022, so we're 2 3/4 years old on this, and he may have solved the problem by now. I hope that's helpful to somebody out there who's looking to attach an old tube amplifier to their transistor rig. Be careful, the voltages and currents may not match. Until we next meet, 73.